lab, I guess you could say. But we're going to be utilizing okay, so we're going to be doing the ideal gas law lab, I guess you could say. But we're going to be utilizing a little bit of Dalton's partial pressures. I can go over both of those in today's lab. So first thing we're going to do is our objective. So we have basically these little lighters. They all have this butane inside of them. And so when we push this button, it releases the gas. That's how we're able to light the fire. Okay, we're not going to be messing with fire today, though. We're going to be in the water. Okay, and then we're basically going to collect all that in this little graduated cylinder. And with that, we're going to come back and find out what our gas law constant is and so forth. So we do have goggles, we have aprons, we have our butane lighter right here. We have a funnel. Let me grab right here. We have our little funnel. And all that that's going to do is help guide it into our little hole on the graduated cylinder. We have our graduated cylinder, which we're going to take out of the little stand, so that'll hopefully be a little bit easier to see on the video. We have a thermometer, so it doesn't really look like one. We have like a little sensor over here, but as you can see, this little part goes into the water. We have our temperature right here. Kind of this little chart telling us that we are going to collect it in Celsius. It'll be important, though, for using any kind of gas law is that we're going to convert it to Kelvin. We do that by adding 273. We're going to be collecting gas in milliliters. We're going to convert that to liters by moving that decimal 3 times to the left. And then pressure, you can see over here on the little screen right here, we're in kPa right now, but we can change that over because we want to be collecting it in, not that one. We want to be in millimeter mercury. So remember, millimeter mercury is the same thing as torr because Torricelli made the barometer, which raised it up 716 millimeters high. Right, which if you look at this, we're really, really close, but we're slightly above it, right? So just kind of keep that in mind where we're located, what the temperature is outside, what the pressure is outside, and that's representing our atmospheric pressure. Okay, so we have everything ready, so we're going to go ahead and get going. So we're going to take this little lighter. We already have our sink filled up with water. We're going to put this underwater for a second. I'm going to open up that little gas. We're going to shake it off, and that's where we're going to get our first initial measurement. The reason why we do that is because we want to make sure that it also has a little bit of that water that was going to get in there anyway. All right, so looking here, we can see that our first piece of data is we have 92. So we're going to put 13.92 into our mass before the experiment. Okay. Now we're going to move on. So get a graduated cylinder, hold it underwater, and fill it. We're going to straighten the cylinder, leaving the top half in the water. We now have a cylinder upside down, completely filled with water. So we're going to do that in a second. Then we're going to put that lighter underneath it, kind of like so. Okay? And so with that, that'll be ensuring that the bubbles are going to go in. Those bubbles are representing a gas, just like when we had reactions, right? So we're going to use the funnel to really funnel it into the graduated cylinder. And what we're going to do is we're going to watch that water level drop because basically all of the gas, it's matter, right? It replaces all of that water. And so we're going to want to get this down to right about here. We're going to be below the little red. So I'm actually going to move this right here so that we can see when we hit that. Okay? All right. So we're going to go ahead and fill this up. All the way to the top. I'm going to carefully put my funnel in there. And that way, we aren't letting any air in. Let's switch my hands with the lighter. There we go. All right, so now what I'm going to do is I'm going to go ahead and push this lever. So that 13.92 was our initial. So now we're just going to collect the gas. So you can kind of see the bubbles that are going into this tube. So this is a very long process. You can stop it for now. Okay, so we're now down to the 30 mark. We're going to try and get ourselves down to 10, so that way at least we have 90 milliliters gas collected. But you can definitely see by this point, we're already up to 80 milliliters of the gas, so there's no more liquid up here. Okay. All right, I'm going to carefully do this. I hope I don't mess this up. Hold on. We're going to take the funnel out just so I have a little more room. Watch that water level drop. So hopefully you guys can kind of see that in the video. I know it's really hard. We're going to go all the way until it hits the top of the red thing, which is at the 10 milliliter mark, which means we would have 90 milliliters of gas. Yeah? Okay. All right. So I'm going to go ahead and remove our little butane lighter. Okay. So the next step is telling us that we are going to because we don't want to go above the markings. So we didn't do that. That's good. Make sure the graduated cylinder doesn't come above the water. As you can notice, I still have my hand in the water. We're going to equalize the pressure to the atmospheric. Raise this carefully until the water level in the sink is going to be level with those red things where our butane kind of stopped right there. Okay, so I'm going to hold it here, and that's going to be our measurement that we're going to grab. Okay, so we had to equalize it because you always have to consider what's going on in the atmosphere, and that way that you know that it's not pushing any more than it should be, just like the so what we're going to do, let me go ahead and get that measurement. We are at 1 above the 10, so we are at 91 milliliters in. Pull this out. So we're going to go ahead and put in our data now. So we have 91.0 milliliters because we were able to, we always estimate 1 after the decimal or 1 more than what was on there. So 1, or we're going to put 0.0. Our temperature of the sink water, if you guys want to look at that real quick, is the 19.8 degrees Celsius. And then our mass of our lighter, we're going to grab that, shake it off to get all the water out again. We're going to see what happened there. So we have 13.69. So that's awesome because what that shows us is that we did lose some mass here, which means we used that butane to fill up the 91. And so now we're going to start the math. Okay, so just to make sure that we wrote down all the data that we needed, what you just saw, the data that was collected, was we got the mass of the lighter and the contents for the experiment, which was 13.92 grams. Okay, then we went ahead and filled up our graduated cylinder, right? So you saw that I inverted it into the water. So we had our water, and then we collected the little gas bubbles until this level dropped to the volume of the gas, which was the volume of the gas that was collected, so 91 milliliters. And remember, I went to 1 decimal place because when you are reading something like that, where you have your lines like so, you always estimate to 1 digit after what you read. So if I read it to right there, then that meant that I put 0.0. If it was in between, I would add 0.5. You only estimate 1 digit. Okay. Then we also collected the temperature that was in the sink, and the temperature that was in the sink was 19.8 degrees Celsius. Okay. The atmospheric pressure, you saw that we collected at the beginning, so that was 760.5 millimeter mercury. And so the rest of these are going to come from our calculations. But up here, after we got that data, so we collected all the stuff, we then took that lighter back out, we remeasured it, and we saw that it went down to 13.69 grams. So now what we can do is we're going to go ahead and calculate this part to get our mass of butane that was released. So let's go ahead and handle that real quick. So we're going to take 13.92. We're going to subtract 13.69 in order to get our answer of mass of butane that was released. So when we do that, we get 0.23. So notice how small these numbers are. Think about it though. If we have particles of gas, right, little itty bitty particles of these gas, we might collect them in a lot, but think about what is actually fitting in that little butane container in the graduate cylinder. So that actually is very reasonable for the amount of time or the amount that we collected.